Hello and welcome to my Twitch. This will be the episode number 3 where we will build decorators in ES6, and we'll do that without using any transpilation. It will just be basically using metaprogramming and thus not needing the actual decorators that will appear in some future JavaScript version, but we'll do whatever we can for now. So for the ones who are here the first time, this is what we did before. We built this deco thing, and what it basically does, you basically declare a function that has almost the same name as the function you're trying to decorate. It is static, and it has $2 That's basically the idea. And then in there, you return the decorators you want to apply. So there are a few issues that I currently have with this approach. And one of them is that we have to basically initialize things twice. So first of all, we need to decorate the class like this. So basically, deco can then find all the kind of functions that want to be decorated and kind of store the decoratables somewhere, so it doesn't have to do that every time. And then basically it attaches a deco to the class, right? And then we call that again, right? So basically we do things twice. I didn't like that too much. So what I realized is that we can actually do this with one call. And here's how we're going to do this. So one thing I want to point out, so right now it's in a pretty good state. We have some code here. It's all kind of still in one function. For instance, the bind decorator is still in here. We'll remove that later. We'll probably separate these all out. But we have some cool tests. So we can basically go wild with this and kind of change things around and kind of have the test to verify that we didn't break anything. So as I said, the first thing I want to change is I do not want to have to call this thing twice. So what I want to do instead is I would just like to do something like decorate this. That's it. And I don't want to have to do this anymore, right? So how are we going to make that work? Well, we'll see in a second. Actually, might not even need this. I might just have to do this. Boom. Right. So, and obviously now our test will break, right? Because nothing will work the same way anymore. So first of all, we have to look at, so that's what we want to do. Kind of went there ahead of myself a little bit. The other thing we want to do is right now we're passing strings in here, right? And then it magically somehow knows what decorator to apply. What I would like to have is make that more explicit, right? It's easier for debugging. Like if you just see this bind string here, you then don't know where should I put a breakpoint if something doesn't work. So basically, but if you look at it though, the bind decorator is like a function, right? So why don't we just, or in this case, it's an object, right, that then has a function inside of it. What I want to do, I want actually to expose these things directly and reference them directly as decorators. Now, that's not the way that JavaScript, kind of the future decorator implementation would work. The future decorator implementation wants to kind of work like this, like you put a decorator like that on top of a function. However, that could very well be changed to where we say, okay, you know what, if you want to do this at bind thing, then there has to be, or we could say bind decorator, right? So there has to be a bind decorator in scope. You can't just put a magic thing somewhere. Actually, a bind decorator has to be in scope. And so then I can like jump there and I can see how this works, right? And that's not how most current decorators work in other languages. But maybe, since we show how nice this will work for us, maybe then someone will consider that for JavaScript. Who knows? So first of all, we want to repair what we're doing here. So the cool thing is that, so basically, just to recap, what we were doing before, right? We created deco and we passing the class. Well, we can actually get the class, right? So actually what we want to do, so I wonder, so yeah, we just want to do it this way. If we future need ops, we just want to, we're going to do this like that, right? So we're going to make the API super easy. So what we're going to do, we're going to pass self, which is kind of this. So maybe what I'll do is I'll open this in two views so we can see the test and the implementation. Makes it easier. So what we're doing here, right, we're just calling deco this, right? So this is in our self. So now how do we get the class from that? Well, it's actually fairly easy. So basically, if we create a class, let's just create a test class. Right, nothing in it. Okay, so apparently I tried this before, so let's refresh. I already played with this. So now we have a test class, right? So now I can say var t is like a new test class. So the question is, how can we then get back to the test class? It's actually very simple. There's a constructor on it, and you can see t constructor is the test class. So what we can then say, is it the same as the actual test class? And the answer is true. So that's actually all we need to do. So we can say const class equals self dot constructor, right? So now we init that. And basically what we'll do, we get the, but the thing is now we create a new deco for all of them. The problem is now, if we call this constructor numerous times, right, we are going to, we're basically going to do all this initialization every time. Now that's bad performance. That's why we had it separate originally. But we can get around that because we can say, well, we're going to have a map, and we're going to actually attach it here as a static map, right? And we'll call it a cache or whatever. You can call it classes or whatever you want to do. So it's weird. Let's call it a cache. So what we're going to do here is we're going to maintain a cache. Well, it can't be this. So it's a getter. And we're actually going to define this outside here in scope. So we're going to have a cache, and it's going to be a new map, right? And so it almost makes no sense to actually have this here. So what we'll do, we have the cache here in scope, right? So now what we can do, we can store, so each time we init something, we can say, well, did we already init this before, right? So so let's see. So actually, so we're gonna have to do the init and the decorate in one step. So the init one, we're going to say, so basically what we want to end up with is this dot decorators, right? That's the final result of doing everything, right? So basically, we're trying to get the decorators. Actually, it's really simple. We're going to look is if our cache dot has class, our class, right? And if it does, then we say this dot decorators equals, and then we're going to get the decorators from the class, get class, and then we're done. So we return. So we're not going to run that init if the cache already had it. Now, if we do actually have to end up here, then we will say, well, now add it to the cache, right? So we're going to set the, and that's going to be the class, and we're going to set the store decorators. So this is now how we cache things, right? Now you may be wondering, wait, like in a hash, like if our cache was like kind of like this, right? You couldn't store like just a class. It would actually toString it, and then if you had, you know, the same kind of class name or whatever, it might get confused. Well, I kind of verified this. So in a map, the ES6 map, you can actually store anything. It's a key value pair, and any value, both objects and primitive values, may be used either as key or value. So that's really awesome because it makes this really simple. Otherwise, we'd have to figure out a string representation for whatever we're trying to cache, right? So, so now we do this, and now, you know what? At this point, our test should already work again. Let's see. It doesn't work. So, okay, so it wasn't bound. Let's see what's happening. So so basically what we have to do now, since we don't decorate anymore manually, right? We're just going to have to do this, and we're going to make this a private method to indicate that we don't want to have this called from the outside anymore. So and then we just call decorate the self, right? We're going to decorate self. So there you go. Let's see if it works now. Server problem. Okay, let's see what is happening. So in the constructor, we deco this. So, oh, okay, here's the problem, right? Create deco. We were expecting, we need to expect the self, right? And then self. All right. Somewhat. So basically the idea of the decorator syntax, I'm going to go into the real quick. By the way, hi user man. I believe that's probably not your real name, but still I welcome you to the feed. So basically I put some links here. I'm going to post that. Let's see if this is a good one. There was a better one somewhere. Maybe that one. I'm going to post that in, yeah, this one's pretty good. So here you can see that it's clearly inspired by Python, right? Because, I mean, this is Python right here. So yeah, the idea of decorators is kind of much older than JavaScript. Decorators were used in Java, C#, Python, I think in Ruby as well. So yeah, but it's supposed to like give us a similar functionality that Python has. So okay, so now we fixed this. So now this actually should work. Okay, cool. So see how our tests helped us, right? So we changed a bunch of stuff. We made a bunch of mistakes, but our tests kind of saved our behind. So so we got that, right? So in this case now, I will actually make a commit. And I'll say API, simplifying deco. Okay, yeah, I don't want to get into hair splitting. So whatever you want to, yes, I agree that C#'s decorators or whatever you want to call them are different. There's sort of like slight difference between languages. So the question is actually a good one if it wants to emulate Python's decorators, and I'm not entirely sure which ones it's modeled after most. But that's basically just the specification, right? That the kind of the suggestion to add to the language. What we're doing here, we can do whatever we want, right? Because what we're implementing are like decorator-like features, but we have full control about how they work, right? So basically, for instance, right now I have this bind here, and then basically it becomes, the decoration works in kind of different ways. Like this, you can, let's see, where did we do this? So apply decorator here. So even like it behaves differently if we need a descriptor or not, and that's for performance reasons and so on. So we have like full control of how we want to do this, right? So it's pretty awesome. So what I want to do now is actually, I want to change that. So I told you that I don't like the string here. So what I actually would like to see is that we actually just have a function, right? So what I would like to see is something like const bind equals, right? I hope that's not going to complain about bind, but I mean it's a function on a function, so it's not a keyword, so it should be fine. So what I want to see is like, you know, you could say deco bind or something, right? Or whatever, however you want to do this, you can say deco bind, right? So you would require it like that. So that's what we're going to do next. so we see here we're using like known decorators to look things up, and I don't think that's like the best idea. This is like magic to me. And also then, you know, how do you add custom decorators, right? Then you'd have to somehow register them with Deco. It's just not cool. I don't like it. So that's the next thing we're going to do. So we're going to remove this thing, and we're going to pull this decorator out. And so first of all, we're going to have to, so we're going to turn this into some sort of a, call it a monorepo or what have you, where basically the decorators live in the same project, in the same repo as Deco, but we're going to publish them separately, right? So if you install Deco, you don't get all the decorators, like you might only want one. So we're going to make a directory here. And we're going to create a bind. And they're all going to live in their own folder, so we can then publish them separately. So what I'm going to do, I'm going to call package init here. We're going to have to add a description, function bind decorator for Deco. Okay, so let's see what I created here. We might have to fix some things. So we're not going to have tests in here directly, so this is fine, because we're going to test it with Deco. It's going to be no depth really. And then so the repo is still Deco. And yes, we will just rely on node 6. So now we are fine. So now we created a package. And what we'll do now is we'll take this code here. And we go back here and we just implement bind.js. I don't like to put index.js everywhere. Because then all your files are named the same, especially if you're using this in the browser, which you can, by the way. So Mojo is a bind decorator. That's it. So that's all the decorators have to do. So this is like our common API, right? All the decorators basically have to export this object that has a decorate function on it, and that indicates if it needs a descriptor. And let's just put a use strict on top. So then we'll fix the main. It's already say bind.js, and we'll fix the name to Deco for now to not run into any. We could try to do a namespace npm stuff, but this works fine. So now we got this in a separate repo, which is package. In the same repo, separate package. Now what we'll do also is we have to make sure that, well, we'll figure out later, but basically we have to make sure that we don't publish, the decorators with Deco. But we'll do that later. We're not worried about that too much yet. So, but what I can do now is I can say I want to get the, see how I put it, decorators bind, right? I want to get decorators bind. That's what I want to do, right? And so here's a little trick. How does it know to get to that file? That's because in the package.json, I called it bind, right? So I don't even have to say bind/bind.js or something. I just have to say bind, and we'll automatically find that one. Okay, so you're good here. Now we have to figure out, first of all, here now, we'll actually just return the bind decorator. Let's see if it's complaining. Nope, so bind is not a reserved keyword. Now what we'll have to do is apply decorators, right? So in this case now, we don't look the decorator up anymore. The decorator is just X in this case, right? Because now X became basically the decorator itself, or like the decorator object, right? So now a test should pass, and it doesn't. Couldn't find module decorators bind. That is interesting, because we have to put a / in front of it, right? Because it's still local. So could still not find decorator. Oh, because we are in the test, right? So we basically what happened was we were like right, we were one deep, so we have to go up first, and now, boom, our test still passed. So we changed the way this works now, which is pretty cool. I'm actually really happy that we figured this out really quick, because then we can go to more fun stuff. So in this case now, we kind of made this work really nicely, because now we can easier debug into like what our decorators are doing. And I'm going to show this in a second after I push this change. So first of all, we're going to make this into 2 commits. Well, actually we can't, because we pulled it out. So let's just make it into 1. So basically, we changed the API, and we also pulled out the bind decorator. So let's indicate this. So how do we call this commit? API using decorator objects also pulled, and this is not the best commit, but it's harder to, we could use patches, but we'll live with it. Also pulled out, or like hunks, also pulled out bind decorator into separate module. Okay, so we got that figured out. So now we get to do some more fun stuff. Now we get to implement some more decorators, and we'll basically test them with deco. So that some people might think that's a bad practice, and almost kind of agree. So what we actually also could do is we could put the tests with the decorators, and right, because we want them to be self-aligned. So what we'll do is we'll actually go over here now to our bind decorator, and we'll make a test for it. So what we'll do first, we install tape, and this uppercase D there with a minus in front of it, that tells tape to that tells npm that I want it as a def dependency, right? So now basically tape was added to my, where'd it go? Somewhere to my def dependencies. There we go. Now we need to, I'm just gonna go ahead here and copy the test script over. All right, because we deleted that earlier. So now we're happy about that. And now we're also going to steal most of the tests actually, because right, that's what the decorator does. So basically, like we're using, since we had no decorator before, we used bind decorator, right, to test our thing, our deco thing, and that might actually be enough. But the same test applies actually to the bind decorator, obviously, right, because it's a bind decorator. So now we have a problem, right? So first of all, the bind decorator now here is actually just the main module, right? So we just go to package.json, and now actually we need to install deco. Okay, so now we're running around into a bit of a problem, because deco is not on npm yet. So at this point, we could go ahead and use, there's a monorepo tool called Lerna. And by the way, userman, I just see a question. I'll get to that in a second. So we could use Lerna, which might be a little overkill, in my opinion. So what I'll show you is like how we, for now, can link to deco. And then later on, we'll publish deco, right? So basically right now, deco somehow needs to be in the node modules folder, right? So all that's going to happen is, if we know our node modules, there's nothing in here. What we can do is we can go in here and we can say, if you're looking for deco, right? What you want to do, you want to go up here, one more. And so this is where deco is, right? Because if we do this, then we would be deco. So we can just remove deco and like do this. And then we say this is deco. And to check this, we can actually now list that and can see that, okay, we are in deco now. So now this is a little trick that you can do. On Windows, you might have to use another linker. There are other link local tools out there. So I'm just going to show this real quick. That make this a little easier. And as I said, you could use a full-blown tool called Lerna. So this This is not the one I'm looking for. Let me find this one because it might be useful to some of you. Link local. So let's see if it finds the right one this time. Yep, this one I'm looking for, by Tim Oxley. So this makes it easier to just kind of link things together. You just declare them in a certain way in your package.json, and magically they will be linked into your node modules. Again, since I mentioned this, I'll show Learner as well, and that's like really like full-blown monorepo manager. And as I said, for our cases, it might be a little bit overkill, so we'll just not use it for now. Okay. So now to your question, user man. Systems made using predefined decorator instead of function-based. So yeah, so basically what I'm creating is a way to kind of say I want to apply a certain decorator to a function, right? And we'll do this by convention by saying you need to create a function with the same name that's static and it starts with $2, but then it has the name of the function you're trying to decorate, right? That's how that works. And then we'll just basically put a kind of decorators in here, and we come up with the convention that a decorator needs to give us a decorate function, and it needs to tell us for performance reasons if it wants to if it needs a descriptor or if it just needs a function. In this case, right, it just needed the function, and so we just pass it the target and the function name. If it needs to hold a descriptor, we'll pass it the descriptor. So that's kind of the API that we came up with for now. And as I see it, most of the decorators actually will only need the function and the target. So the target in this case is this, obviously, right? And so then you can do in that decorator whatever you want. So we just have the convention that either we'll give you the function name on the target, or we give you the full-blown descriptor in the function name, and then you do with whatever you want, right? So and for again, for whoever is like watching this first time, by the way, I'll post a link at the end of the show. Actually, I'm going to do this now. If you want to watch on YouTube, you might see where did I put on my playlist? Okay, of course now I can't find it. But I had it like a Twitch playlist. I have like too many playlists, as you can see. Where is it? No, I can see it. Okay, but there's a playlist somewhere where you can watch the other 2 episodes. So maybe if I go to my channel, maybe they'll show up there. All right, so here we go. This is episode 2 and episode 1, so I'm going to try to find this. Okay. Okay, somehow it's on the playlist. I'm just going to put this in here. Actually, I might put episode 1, and I hope it will then lead you to episode 2. So let me put that, and then I'll explain what I wanted to explain. All right, cool. So anyone wants to watch the previous one? No, you can. So basically, what I wanted to explain was that here basically we're overriding the function on the target, which is like this. We're overriding it with the same function, except we bind the target. That's how simple that was. So we get the function off the target, and then we assign it to another function that is that function, the original one, but bound to the target. That's pretty much what we're doing there. Okay, so now, as I said, we don't have, we test, right? So we don't have deco installed, but we don't need it because now we linked it in. And we're going to actually have to figure out after we do this how to publish all this stuff to NPM, right? That's the next step. And then we implement more decorators. So here, let's just run this test, and it passes. So cool. But before I publish this, obviously, and check this in, I need now to publish deco. So we're kind of in a little conundrum here, right? Because if there's no deco, you can't use deco bind. Well, you could, but you can't run the tests. So now, what we need to do, we need to say, we just want to publish. So right now, I'm going to use a tool that I wrote, which is Irish Pub. it's on, you just install it globally. And what it does, it kind of does what npm would do, and it tells you what kind of stuff would be published. And at this time, right, we see that, oh wow, we're publishing all this stuff. What we actually really only need to publish is deco, right? We don't need to necessarily publish the example. Tests would maybe be nice, but let's just minimize it for now. And so what we'll do is we'll edit the package.json, and we add a files. And I hope I remember this right. And then basically we just say deco.js. And now npm should only publish that one file. So let's see if that worked. Oh, there you go. So what it always includes, so obviously the package.json, the README, which is useful, the license, and deco. So that's all we need. So now what we need to do though also is we need to update our example, because now it doesn't work anymore. So, right, the example now just needs to say deco of this, and then we're done. Just simplified a lot. Okay, fn is not a function. What do we do wrong? Okay, so we discovered a problem. So let's see what we're doing differently. Let's close this one. Let's put the test in the other half and see what are we doing different from the test. Oh well, yeah, we need bind, right? So so what we'll do in this example, we'll reference it directly. But when we publish it to the README, when we put in the README, we'll just basically replace it with deco bind. So like that's how you would install it. Okay, so that worked. Now we'll take this example. Let's see. Right, take this. Okay, and so what we'll change is deco, right? We require it like this, and then we call this deco bind. Cool. So that works. So for now, we'll remove this nix nada nichiwa thing. At this point, we will not put a API thing. It's very simple. You just deco this. I don't see much of a point to document the API. There's only one API, deco this. It's really, really simple, right? Well, at some point we'll have to document also that you have to do this stuff with $signs. But for now, just to publish it, this should be fine. So what we'll do is we say, hold on a second. So we didn't include the decorators. So actually we need to do that because we said in the previous commit that we did, right? So we need to actually amend the previous commit that we did here, right? Because we said we added bind. So let's do that. And now basically we'll actually just only will update the README in the example in this commit, and basically we'll say that doc updated examples to API changes. Okay, and then we'll add the package.json, and then we'll say npm only publishing deco.js. All right, cool. So let's kind of make sure that's all going on. So we only would publish this. And so I think at this point we are ready to publish. So yeah, we amended the commit, so we need to force push. So now we're going to, so right now the version is basically 0.0.0. Since this is kind of like, we still need to document the API well and stuff like that. Things might still change. We'll just publish this as just a patch, kind of to indicate that, hey, this is not really 100% yet, but we still want to already publish it. So I have the script. I'm just going to put this here, which basically tags, right? It pushes, tags, and then publishes to npm. So we'll use that. And hopefully deco is still available. It was when I last checked. All right, so cool. Now we got deco. Very nice. So now we will go into here, and what we'll do is we remove our deco link, and we'll install it just to make sure that this actually works. So we just install this as a def dependency, right? Because if you're installing this bind decorator, you don't want to have, we could make it a peer dependency. I don't like peer dependencies as much. And also you could use this with maybe another tool. I mean, it's just a convention, right? So let's just see if the test still pass. Okay, so now we just need to basically document it. We need a README. Could I repeat why I need the bind? Hi Bedroom already. So why I need the bind function is, so if you're, actually we can show this with this example here, right? So here we have hello, and this could like be a click handler, like let's say you're doing React or whatever. And what usually happens is then you say, you create a component, let's say whatever your component is, right? And then you say on click or clicked or whatever it is, I think it's click. Then you say this dot on clicked, right? Now, at this point, you're just passing the function, and it's no longer bound to. So if I now call it over here, right? If like the component now calls it as a function without calling this dot. It just calls on click. It just gets some function, right? And then basically this context, unfortunately, in JavaScript, will be lost. So that means then if I console log this.hello, this will not be the world class. This will be something else. So then it can't find the hello, right? Because it doesn't exist in the context. What you can do though is you can say this dot on clicked equals this dot on clicked dot bind this. So this essentially creates a new function, and now we basically, or we can just, right? And now basically if we pass it to the component, now it's bound, so we are happy, right? Because now it's good. But the thing is now we have to do this everywhere. Yeah, so you need to bind in the constructor. Well, the thing is that I hate to do that, right? So what I wanted to do is like I wanted to be able to look at this function, and I know it needs to be bound, and I want to see right here if it's bound or not, and I wanted to do this quickly. So this is where we came up with the idea why why don't we just have a decorator, and then it happens for us automatically. So that's what that bind decorator does. It will automatically bind this function for us. And obviously, like as I said, there's a proposal to add decorators to the language, kind of like you would just have to type this, right? However, that's currently not there. You can do that with something like a transpiler like Babel, but for various reasons, I like to, in my node programming, I don't like to have a transpiler. I just like to run the code as is, right? So, and the other reason, obviously, you want to kind of play around, like, on Twitch, you want to do some interesting stuff, right? So, wanted to do some meta programming a little bit and see what's possible in JavaScript, even today, without any transpiling. So, I hope that answers your question. So that's kind of what we're doing. But this is not only for bind, right? The next thing, once we write the README, we'll actually go ahead and implement another decorator. We'll most likely do a debounce decorator today. So that's kind of an idea that I had. So we'll get there once I write a README. No problem. And keep asking more questions if you have any questions. That's why I'm streaming this. Otherwise, you could just watch the video, right? It'd be boring. So we'll kind of plagiarize on our own stuff here a little bit. So to get the README going, we also will copy the license. We copy the license here. So we got a license, and then we'll edit the README. Okay, so obviously this is deco bind. So let me actually close this so I have more space. Deco bind. So the interesting thing here is that this example So we'll put a link to the GitHub repo in here. Okay, so that's good. Bentacle for deco. So this is how it works, right? And basically, don't have to do. We do this to make sure that people know that they install deco with it, right? Actually, I don't like this so much. It's pretty obvious that you need deco, right? We said for deco, we require it here, and so on. So now we have a README. The benchmarks, actually, these benchmarks are very relevant to bind because we're basically testing bind in here. So these benchmarks we leave in here, and at this point, I think we are ready to at least publish a kind of a patch version, right? So now let's say we're gonna run Irish pub again, but there I'm gonna put, if you're interested in, there's another one. There obviously, you know, with everything npm, there are 300 modules for doing everything. Okay, so that's interesting. So by the way, some of you may have noticed that there is some things that GitHub now does to check out your dependencies and you have vulnerabilities. So what's happening here is the tar dependency has a vulnerability. Okay, so I don't think that's too much of a problem since we are not using it on the server, but I will actually right now go and fix that. So you can watch me do that. So let's switch to another one. And I will go and, first of all, I will post the link. So this is basically what it does. It does exactly what npm would do, and then it tells you exactly what npm would have. Basically, it looks at, it calls npm publish under the hood, or npm pack, which runs before npm publish. So it knows exactly what npm would publish, which is really useful. So what we'll do is we'll go to our project, and we'll just clone Irish pub. So by the way, this is hub that I'm using, which knows automatically, since I'm TH Lawrence, where to clone it from. Kind of useful. What I was complaining about was, so first of all, we run, so we have no dependencies are not installed. So we have readable stream and tar. So what we'll do is we'll remove tar, and then we'll reinstall it. Then should be happy, and see what else is complaining about. Let's say actually readable stream we might update as well. Well, actually first, yeah, let's do that. Let's remove readable stream. Nope, readable stream. And let's update it as well. Okay, now we run, so now we should actually have all our dependencies, except we don't have tab yet to run the test, right? So we just run install, run a test, they still work, and now we have failures. So we have some, okay, so here we go. So we have to change something. Make sure you keep that arrow over here. And so it seems like the tar wants to be invoked with a new now, which is kind of a reasonable warning. Can it be, and that's on line 62. So let's do that. Obviously, as you can see here, I'm going to turn off Syntactic to not annoy us because I was still using a different style of JavaScript when I wrote this. I don't want to rewrite everything now, just to update my dependencies. Looking better now. It's stuck. It might be because the engine is slow. If this turns into a little bit too much, I might just stop here and like, okay, so we have a failing test. Huh, this is tricky. So basically, so see, we're basically running npm pack here. So I'm not sure at this point. So like this is like where I made a mistake to update like 2 dependencies at once, right? And I'm running with a much newer version of Node. So we'll table that. Okay. I don't want to bore you with this kind of stuff. So what we'll do is we'll use our Irish purposes and hope, so this vulnerability most likely doesn't apply in this case because we're just running this as a command line thing, but obviously ideally we want to fix it eventually. So what we can see here now is we would publish a bunch of stuff which is not so necessary, especially with this one. If you include the readme, right, since the readme is basically the test, we don't really need to include the tests. And that's basically all the extra stuff that's included. So we just only say bind.js, and now we'll actually see that it will still include the readme and package.json and license. So that's it. Okay, cool. Now we can say and license, right? And now we can basically version it. Again, we'll also version this to a patch version. And let's just run npm test here again. Okay, and then we'll run our little EA script. And boom, we'll publish this one. So I named it deco bind, which is cool. So now we should have this already. Okay, cool. So this is basically how you can do a mono repo in a very simple way, right? Because it's still all in one GitHub repo, but it is it's separate modules now. So you can then pick and choose, like, which one do I need? Like, do I want to, right? So you see this updated here. So build is unknown. So let's make sure that we actually fix Travis. So why is activated repository? Okay, so we have activated it. So the uncool thing is now, okay, so here's the thing, right? So now we actually have a problem because now we can't tell it to run. So we have separate tests here in bind, right? But it's all in the same repository. So what we actually have to do is we have to tell the test script to also run the tests for deco bind. So what we're going to do is test deco, and then we say test bind. I'll just call it deco bind, right? And so what that does, we'll basically just cd into decorators, I think it's called bind, right? And then we run npm test in there. Okay, and then we will have a mother test script that will run all of those. So we run npm run test deco and npm run test deco bind. And now it should actually test everything. So what's going on here? Okay, we're missing a quote. All right, cool. So now if we run tests, we should actually see them running twice. So there you go. So now it ran also deco bind. So now let's look at our Travis. We want to make sure 6 and 8 is fine. So actually, so now, so what did change in? Oh, we published this before. Let's see what changed in decorators. Let's see, what did we change here? Oh, we added. Okay, so basically when we ran I don't know which one we ran the version, so then it changed this. So we upgraded the version, that's fine. So we'll just publish that first. And we'll say bind versioned. So dot proto, the relationship here is that the decorator proposal, is not in the language yet, right? So the problem is, let me actually open the test or whatever to show this. The problem is that there's no way to kind of hack this like that. You can't do that. Even if I save, it will already complain, because that's not part of the language, right? So you can't use existing runtimes, right? ES6 or whatever, to understand this. It doesn't even understand what this is. So there's no way to get, to do something and then kind of shim it, right? You can't shim it. It's like if you're using something, kind of like a keyword that's not even part of the language, you can't shim it. So basically, I want to use decorators before they're in the language without having to transpile. So yes, I came up with my own convention saying that, if I want to put a decorator on a function, I will basically implement another function that's static, has the same name as that function that I'm trying to, in this case, bind, plus the $signs in front of it. And I'm using $2 to make sure, not pissing off some people that like to use jQuery and, kind of want to have $1 in front of some function. So, and why am I using dollars instead of like at? Well, because this. That doesn't work. You can't put, in the current language specification, you can't put an at in front of a function either. So otherwise, that would have been an awesome way to do it. But that's basically it. I want to, use meta programming kind of to shim decorators in before we even have them officially in the language, without resorting to a transpiler like Babel. Because in Node, I just don't want to have, I don't want to run transpiled code. That's just the short of it. If you're more interested in why I don't want to run transpiled code, you can ask me. But I already explained that somewhere in episode 1, I think. So let's just stick with that for now. Okay, so we published deco bind. We published deco version. We did some changes in the repo. We did some changes right now to the package to run all the tests. So let's do that. Okay, cool. Proto. Running a bind decorator test. So basically, we're including the this one in the test suite. So now basically, if you push, we don't need to publish a new npm version because it doesn't change anything about how things work. It's just like how tests work. There's no reason to publish a new one. So what I'm going to do is I'm going to look. Okay, now our tests are kicking off over here. So I'll have some water. We'll kind of look at what's going on here. Also to make sure that we're not using any features that are not part of of Node 6, right? Okay, so while that's going on, let's look at debounce. So there's a decorator out there of the deco. Let me clean up my tabs a little bit. So basically there's a deco project that has implemented its own decorator for debounce, which is kind of nice. So it's in here, and it's basically debounce. And what he basically did, he implemented the decorator part, plus he implemented the debounce part, right? But actually, we don't need to re-implement the debounce part. There's already a debounce module out there. So, by the way, for those who watched the first episode, I mentioned that I may want to try to use these decorators as well, instead of implementing my own. But the thing is, we already have bind now, right? And they all kind of work in mysterious ways. One works with the target, one works with the function. They all have different APIs. We want to have a consistent API. So, but most of this code, for instance, here, all that's just debounce. So what we'll do, we'll go to npm, or we could also actually use npm search, because that gives us points right away. So let's debounce. Let's try to find one. So we got an action debounce, a react debounce, promise debounce. All not exactly the ones I'm looking for. I'm looking for just a single debounce. So in this case, what it does, it gives us the ones first that are updated latest, that have really good points, that have really good tests and all this stuff. But in this case, I kind of know. So if you're generally looking for which module to use, this is a good tool because it gives you points. And you can kind of look at what's considered safe, and what's considered stable and so on. So in this case, though, as I said, I know pretty much exactly that I want this debounce module. I think that is it. Yeah. So see how many collaborators it has? Pretty good. So here's like the README. And so what we'll do, we'll implement a new decorator, and all it does is debounce. Cool. It's going to be fun to test though, because we have to make sure things get debounced. So what we'll do now, so I'm going to name my, so this is deco. This was bind. We don't need bind anymore. We're done with bind. So, and let's make a new one, debounce. We're going to have maybe problems installing debounce. NPM doesn't like it if it's the same. But okay, let's see. So what we'll do, we'll be really parameterizing ourselves now, and we'll copy the package JSON from our bind, so we can just modify it. So decorator, and we'll call it debounce. Everything else pretty much same. Def dependencies, fine. One thing, by the way, we made a little mistake in the bind, I'm just realizing. So yes, we do need bind again. So let me actually, I don't know if anyone spotted that mistake, but we basically, our tests, they were still, okay, no, they're actually good. And we did remove it originally from the node model, so actually we're good. Okay, cool. I just wanted to make sure that we actually made sure we can install deco correctly and use it like that. Okay, so now, so the files obviously is going to be debounce. So it's the same. Okay, so cool. And what we're also going to do, and I hope NPM lets me do that, we need the debounce module. Boom. So hope that, did it do that? Yes, it worked. Okay, sometimes it doesn't really like to do that. So now we're going to also install tape to have some tests. And now we basically going to implement a very similar test to bind, except now it's going to debounce. And then we're going to make sure that it got debounced. And like, how do we make sure that? Well, we're going to call a method like 10 times in a row really quickly. And we're going to make sure that it only got called once, right? That's basically how debounce works. So for those of you who have not used debounce before, debounce is for things like if, you know, let's say you have a best example is like a type ahead, right? So if I'm like typing here really quickly, do you see how it doesn't update all the time? Like, you know, if I type like Google something and then I type something else, then it takes a while for it to, it doesn't like update on every letter. Look, I'm typing, it doesn't update, right? Because it doesn't want to make that network request all the time. That'd be a waste. So what it does instead, it says, okay, I'm going to, you know, debounce a function, meaning that, you know, while you're typing, if there's not enough time in between one letter to the next, I'm just not going to do anything. So in this case, that would be 200 milliseconds. So here we also can see there's a resize, right, reaction. So if the window's resizing, right, if I do this, right, and then you re-render every time, that's just crazy. You probably want to wait till I'm, you know, done resizing, and then you can do something, right? So that's pretty much what that does. So so what it does, it takes a function and it returns a new function, right? And in this case, we assign it to window on resize, and that function then is debounce. You can actually look at the code. The code is not that hard. This is actually a good example. I'm actually going to post that in here. This is a really, really good example. If you're new to JavaScript, you want to learn how it works, some kind of cool tricks, this is a really good example of code to read. I will totally recommend that. So if you take nothing away from here, but read this module, you will have learned something. So now we need to basically use this in our code. So our own debounce.js. So what we'll do is we'll first of all require the actual debounce mode. So basically we were wrapping, right? We are kind of using the real debounce that's already implemented, and we just make it into a decorator. Now what we'll do, and so this is kind of where, you know, if you're doing similar things, you can see a monorepo really comes in handy. Now we can just go up here and look at the bind and kind of review how the can basically copy and paste this code, how the API worked. So we change bind everywhere to debounce. Okay, cool. So what we'll do, and in this case now, we'll need opts, right? Does it make sense? Why do we need opts? Well, because we need to somehow define how long to debounce for. So what we'll do, we create a new function, right? So this is the original function. Now we overwrite this function with a function that's debounced. So we can say that debounce, that's it. But we need to know for how long, right? So what do they call it here? They call it immediate. Okay, so there are several options here. The wait, the immediate, and if it's immediate, right? So we'll take all this into our, we'll make this all into an option thing. So wait, the default, do they have a default here? So we have to pass the wait, I think. There's no default. So we will have no default. Let's see what happens if there's no wait. Oh, look, 100. So we'll just also use that. That's fine. Probably wouldn't need it, right? Because we can just pass nothing and it will be 100. And then immediate, and the default here is false. Okay, so those are going to be the ops. And as you can see, we're using destructuring here. That's because we are already using like ES6 classes and everything, so we might as well use other ES6 features. All right, cool. So so these are the ops. And then basically what we'll do, we pass wait and immediate to our debounce function. So that should be put the debounce here. Okay, and then we'll export that. So now we have to figure out how to pass options in, right? So now it's going to get funny. So what's going on here? We need equals. Okay, so now we're fine. So basically this is implementation. However, I feel like deco needs to change. And again, another reason why having this together in one repo makes a lot of sense. So basically what I'm doing now is I'm going to, first of all, make clear, so let me see, it should already be a def dependency because we copied the package.json. So we made sure that deco is a def dependency. We may actually have to change this to star because we want to be up to date with the latest deco. So let's actually edit the package.json here. And we'll also edit it for a bind, right? Same story there, and we'll publish that separately later on as an update to bind. Do not worry about that too much. I just do it now so I don't forget. Okay, now what I'm actually going to do though is I'm going to get out of here for a second, and actually let me name my tab. Okay, so in the node modules right now we're actually using the real deco, right? But as I said, we may need to have changes to deco to make this work. So I'm actually going to remove deco, and I'm going to link to our local deco right here, right? I'm going to link that to deco. Let's make sure that we did this right. Okay, cool. So now, now we can basically go and start writing the test. So do we have a test for it? No. And we'll basically say test debounce. So now what again, we can steal most of the code since this is, it's very similar to what we're doing with bind. Right, we need to install this, we need to install that, right? We need this class, but in this case we're actually going to be have a debounce function and a not debounce function. So and then we're going to get to how we do this in a second. So this, we're not worried about bound or whatever. So actually on click is not so bad. it's called onTyped. So, you know, because we talked about, so type debounced. And so what we'll do is we say debounce equals require, right? And again, since I have in the package JSON, well, I need to put debounce here also. And okay, put deco, fine. Obviously here we made a mistake. This should be deco. We need to also fix it in bind. Let me actually just do that right now so we don't forget later. Right, because it's all in the same repo. So there you go. So now basically have debounce here, and that's how it works in the test, right? If you just go one up, it finds the package JSON. Package JSON tells it where the actual file is. So cool. So now what we need to do, we need to put a debounce here and call onTyped, right? And then here we have a normal typed. So now what we'll do, actually in here we will count how many times did we actually call. So so this dot debounce count 0, and then this dot undebounce count, if that's even a word, is also 0. And then in here we just say this dot debounce count plus plus, and here we say undebounce count plus plus. And then basically what we'll do, we'll call, we don't need the hello anymore at all. We will call this onTyped debounced, okay? So we call this multiple times, and then we should get different results here, right? Because if it debounces correctly, then, you know, if we call it within, like, let's say 100 milliseconds 10 times, right? But it should debounce by 100 milliseconds, then we should only get one call, right? So that's what we're going to do. We're actually going to remove this for a second. So so let's first see, we are going to actually just write in this file as if it's not even a test. We're just going to play around with this for a little bit. And then we'll convert it in a test later. So we have a new world class. Let's see if that even runs, right? Okay, so that worked. No complaints there. And actually what we're going to do, we're going to just console.log the world class dot if something happened there. Function. Oh, look at that. It looks like it did debounce it. Look at that. It already worked, but we still cannot, you know, decide. We still cannot decide like how much to debounce it for. But so basically, what we'll do, we need to basically when we, so basically here we're going to take debounce ops in the future. So what we'll say is we'll say wait. Let's think about this. So right. So basically what we want to do, we want to be able to say this instance is debounced by this much, right? And the other instance is debounced by something else. So what we'll do is, for now, we're going to do 100. And we know that that's the default, right? So we're kind of like tricking ourselves a little bit. So we'll first write a test that shows that that works. And then when we see that that works, we write a test that proves that it only works for 100. Like we write a test for 200, and then it will break. And then we can write actually the code that actually reads the ops correctly, right? But we want to make our life easier. We go step by step. First of all, we want to make sure that this works and it keeps working, so we'll have a test for that. And then we go to the other stuff. Makes sense, right? You don't want to have too many things in your head at once. So that's what tests are for. All right, so make sure I went back to null. All right, so now my cam is over the code. Well, yeah, that was for a second. That was my effect beam already to like just like talk to you guys and girls. So yeah, I can do that. Look, It's over the code now, and now it's not over the code. But if I somehow forget to remove it, then please let me know. That's why I checked over here, but now it's fine. Okay, so let's now create a new world class. And so we'll just basically say with default values, and then what we'll do, we'll say world class dot, we call it, so we have a tight for loop, and we call it like 10 times. Right? And in a second, we're going to have to, we have to find a better way to do this, but right now it's a tight for loop, so we're going to call world class.onTyped debounce and then onTyped, right? And so now, when we're done with this, we're going to console.log world class dot, actually makes this, we don't need this to be private, this is for a test, so we want to actually be able to access it officially. So we say debounced count, and then undebounced, well, just type it then, world class dot undebounced count. Okay, so now let's see, they should be different, right? So anyone want to take a guess what the result should be if I did this right? So obviously you're calling it 10 times, right? So for undebounced it should be 10. What should it be for debounced? Anyone want to type it in the chat before I run it? And then we'll see if it even works. So let's see. All right. Okay, so yeah, we need to make sure that the options are optional because they are options. All right, look at that. Debounce was 0. That is interesting. So yeah, because we didn't wait yet, so it actually didn't even call the function yet because it's waiting for the 100 milliseconds to expire. And that's when it's going to say, okay, I'm going to then take the last call, and I'm actually going to do that call. Right? Does that make sense? So, so basically what we'll do is we have to put a timeout here. Let me think about a nice way to do this. Well, let's just do it the plain way. So we'll put a timeout here, and we say check result, and we'll say 100. Right? Let me call it, let's check result. So let's see what result we get now. Okay, perfect, right? So it's working. Yay! It's working. I didn't expect this to work right on first try, but it is. So now all we do is we put a test around it. So test basically using default opts, right? So to make it a little easier to read all the tests, once we have multiple, it will be harder. And then we put the for loop. And then we say calling event 10 times. We'll say that now we're going to make assertions. We're going to say t dot equal this one. I'm going to fix the equal in a second. Equal 1 calls debounced, or debounce executes, right? Because we're calling debounce multiple times, but executes one time within 100 seconds, right? And then the other one, the undebounced one, on the bounce executes 10 times. All right, cool. So you saw how easy it was to then go and convert my little script into a test, right? That's what I love about tape, by the way. It's just JavaScript. So something is unhappy. No blank lines. Okay. Boom. We got tests. So we got the first implementation. And I'm going to do the little trick again. Beat them already. So now, though, we're going to have to find out if it works if we change it to, like, let's say 200, right? So now if we pass 200 for the wait, then, and we wait 200 milliseconds, it should only still do it once, right? Or let's actually say we pass 10 for the wait, and then it should do it one time. If you did it wrong, or if you didn't do it yet, it's going to do it 0 times. So let's do that test for a second. So you're going to do the same thing 10 times using wait. We're going to do a wait of 50. So now we should. So we're gonna say. So within 100. Let me think real quick. If you do the set time for 50, right? Now it should have called it one time, right? Like it's the same thing. We just changed this 100 to 50, and that's it, right? So now this should be still 1, and this should still be 10. However, now obviously we need to change this to 50 as well, right? However, most likely it will fail because most likely it will be 0. There you go. Expected 10, 20. Okay, haha. We need to obviously create a new one. So let's actually put that in here, right? So, and now we're going to assume that we actually already implement this, right? So we're going to say wait. We're going to say 50. It's not going to work though, because we don't do anything with it yet. Okay, so 0, right? Like I said, well, not working. But the cool thing is we still make sure that the other test is still running. So while we're changing stuff now, we can make sure that we don't break things. So what I'm going to do now is I'm going to pass these options here to Deco. So now, boys and girls, it still doesn't work. And why? Well, because Deco doesn't have that feature yet. Deco is incapable right now of passing along options. So we need to make it do that. So the funny thing is, now we're actually testing Deco with this, right? Kind of weird, right? But the thing is, we most likely will do something similar where we basically have a decorator that does nothing, and we'll just make sure that the ops are passed along. So we'll make a simpler unit test in a second for Deco. So now let's see what we can do here. So basically, we're calling Deco here, right? And so now we need to take ops. And these ops are meant for the decorator. So let's call it decorator, so it makes that clear. Ops, right? And obviously, for those who are watching closely, we need to also, take that in here, right? So the class in it doesn't change anything. Here, though, we need to pass the decorator ops along, right? And what we'll do is we'll simplify this by saying if you don't pass anything along, we'll just automatically make it at least an empty object. So now we can at least assume that we have something that's not null, right? Good point. Very good point. Very good point, Ideal. Very good point. So for those who are paying attention, he's got a really good point. How are we going to have a different weight for different decorators? And I think we have been doing this all wrong. So I remember now, that another way I wanted to do this was to basically be able to, do this. So you want to actually do this here. So this is a funny conundrum. So either we can do this per instance, right? By the way that we're doing it now, but then as Hideo points out, it will be the same for every function. That's not cool. I think it makes more sense to say, well, in general for this class, I want this function always to be debounced like this. And then obviously if that's not working for you, then you can still do, not use the decorators. Then you can still debounce this function manually, right? So really, really good point. So what I think what we'll do is we'll use the exact same API that the debounce module uses, except we will omit the first argument, which is the function, right? Because the function will be what deco will give it, right? The function deco will find that function and will pass it in. So thank you very much for that point. We were a little bit on the wrong track. So what we do here then is we can say so what we'll have to do is we have to actually rename this first. So we have to hold our horses. We'll remove this entire test. So we'll make multiple functions. So what we'll do, we'll make multiple functions that are each debounced separately. So we'd say 100 here, or we say default. And then basically what you have to do, you have to call debounce, right? So now that allows us to configure that particular debounce decorator. So that's the debounce default. Okay, and then we make one that has 50. So we just change default to 50. It's a little bit ugly, but it's a test. So, and now we'll pass 50 as the first argument, right? So now basically we are allowing passing in arguments. So okay, so now all this goes away. This was not a good idea. We may have to, well, thanks for getting here and helping us out. That's the one other reason why I'm streaming this. So, whoever just arrives and sees something wrong can save us a lot of time. So let's see. So we don't want to, all this, so let's just undo everything. Okay, right? Okay, now we're good to normal. So now actually the cool thing is though that we don't have to actually change deco. So now we have to be a little bit smarter. Let's see about how we can make that debounce thing work like that. So let's see, we have the debounce here. So what we'll do is first of all we have a function configure debounce. That's basically what we're going to export. And we have a weight, which will default to 100. And let's worry about the immediate weight in a second. So then basically now you basically get configure debounce. Okay. So now how can we do this? So basically I think what we actually, I think I have an idea. So what we'll do, we'll actually make this ops. And what we need to do, we need to somehow allow deco to get ops. So basically we're going to put the default ops here. Actually we don't need default ops, but what we'll do is we say return, and what we'll do, so here's what we do. Basically what we're doing, we're going to put these ops here. So then deco will find the debounce decorator, and then what it will do, we'll pass these ops in here, right? So basically what we can do now is we don't need any defaults anymore because we know the ops will be set. There's no way the ops will not be set. So we can just do that. And we actually also don't have to do this stuff. So configure debounce, we'll get to that in a second. So basically the configure debounce will basically return what module exports returned before. So that allows us to actually call it, and then it will return the debounce decorator. Before, basically, we were returning this thing, right? So that thing. So what we'll do now is instead of returning that thing directly, we are going to export a function that then returns that thing, but that allows us, before we return it, to configure it like so. So basically what we do, we make sure we don't overwrite the debounce decorator for everything. So we do the debounce decorator. So what this does, it will create a new object, this one. It will then inherit all the properties that are already on the debounce decorator, these two, and then we will add the ops. So actually what we'll have to do here is make this a little nicer. It's kind of funny for Twitch, to make it easier for you guys to see, I have to make my fonts pretty large, and then I realize that I'm always going way beyond 80 characters or 80 columns. I have to change the code a little bit. So basically what we're going to do then is we'll basically actually, you know what, we do it this way. It's actually simpler. So we do that. Because we don't want to have this object assign thing to be complicated. So we'll just do ops here. Let's do it this way. So we don't have to have, so we know up here, we know we get ops for sure. Because what we do here is we'll do these ops. That should work, right? So now if we pass nothing, ops will just be empty. And so basically what I'll do, I'll call it decorator ops, just to be a little bit, well, let's call it config maybe? What do you guys think? Ops config? Let's call it config. And so we'll call it config as well up here. Okay, cool. So now basically this allows us to say pass in this config, and then we'll give you a custom debounce decorator that has that very config attached to it, right? So now, at this point, right, our test should still pass because we're using the default, right? We're using the default here. So if you call debounce here with 50, and here we're just calling it with default parameters, so we have to change it a little bit here. We have to make this default. And right, and then undebounce we don't need to change. So debounce, we call it 50. Okay, cool. So we can now kind of test things isolation. That's nice. And now basically what should happen here, the debounced default should be 1, right? As before, right? Because we didn't change anything yet. So this test should still pass, and it doesn't. Cannot destructure property, blah, blah, blah. Well, in this case, because we're not using the config yet, so I can easily fix it like that. Let's just do that. That'd be nice. Untyped debounce is not a function. Untyped debounce. Oh, because we're calling it here, right? Untyped debounced default. All right, cool. Now our tests are passing. Okay, so that, but at this point, now the ones with the, now we could say also that we're calling world class dot on type bounds 50, right? So now that should have been called 0 times. Right? So debounced, default debounced executes 1 time, and then actually using default loops doesn't make any sense here anymore, right? So default debounce executes 1 time within 100 milliseconds. Then the 50 ms debounce should execute 0 times within 100 milliseconds, and then the undebounce should do 10. And right now what will happen though is, since this 50 is not at all honored at this point, right? That means that that it will just execute also 1 time, which will make the test fail, right? So it also execute 1 time. So we can fix that though, right? So let's go back to our debounce and look what's going on here. So basically, we are passing in a config. So we need to, first of all, it needs to be weight 50, right? Still, the test will fail though, right? But now we can fix it. Basically, all we need to do in Deco, when we call the decorator, we just need to pass along the opts. So where are we embedding? So decorate, apply decorators. So we decorated them. So we have the decorator, the target. Okay, cool. So you have the decorator here. So we need to pass the, okay, so if you have a descriptor, now it gets tricky, right? So the descriptor should always be last because that will not always be there. So basically what we'll do, we'll say the decorator dot config, we pass it in, and here as well. And as you can see, like right now, we're not testing this code pass yet, right? Because we never had a decorator that needs a descriptor yet. So it's a little hairy. We will only realize if there's a mistake there once we have one that does have that. So now we're passing the decorator.config, and it, you can see it's a little bit magic. And again, the decorator needs to know that it needs to add the config, right? But that's kind of a convention. We can just say, okay, you just have to follow that. We'll have to obviously indicate that at some point in the README or something. Okay, so now let's see. Okay, we're still failing. Let's see why. Okay, so we got the decorator here. We got the weight 50 here. Passing the weight in there. Okay, so okay, so it should have. Let's see. Okay, so if anyone sees anything that I'm not, let me know. Otherwise, what we'll probably do, we'll just run this test with Budo. So most of you already mentioned Budo too, especially if you have been in the last few episodes. So Budo is this cool thing that just allows you to run a file in the browser directly. So you can use it also to prototype in the browser. It basically runs browser VFI under the hood, does a bunch of cool stuff. But basically what you can do is you can just do this, Budo index.js. So what we'll do, we'll just go to our test, and 1 for 50. Shouldn't it be 1 for 50? You mean the test, right? Let's go back to the test. Well, actually, you're right. It should be 2 for 50, right? Because we're told it like within 100 milliseconds, it should be 2, right? So, but it's only 1. What if we make it 110? Maybe there's a weird race condition. Okay, it's still 1. So the thing is, it still seems like it's no different than the other debounce function. Hold on, what's going on here? Okay, yeah, we didn't change our message. So it should be 2, right? So 0 was actually wrong. It shouldn't be 1 either, right? Because if we were waiting, actually you got a good point. So basically we're doing a timeout, and like within the, right, the timeout doesn't happen. So our test is flawed. So we may not need Budo. So let's do 100 again. So basically what I'm going to do, we're going to do 2 sets of 50. And we're going to call 5 times each. We're going to make that a function. Call it run loop. Right? So we run the loop once. And then we'll wait 50 milliseconds and we run the loop again. Right? So here's what we do. Run loop. Then run loop again. And we'll set a timeout for, let's say 100, and we'll check the result. There's a nicer way to do this, but this should actually work. So, right, so basically what's happening now is the bounce 50 count should see 2 because we're running this. Okay, now nothing works anymore. So it's all 0 now. Okay, so that's interesting. Let's see, onTyped ran, onTyped ran 10. Okay, that's interesting. So that works. We run the loop. We call each of these functions, right? They should be debounced. So they are definitely bounced because they're behaving differently than the other one. However, they're both so let's do this a little nicer. Loop runs 0. So then basically we say loop runs plus if loop runs. So if we did 2 of them, right, then we'll actually check the results. Right, we do that. Otherwise, we just do another run loop. We set another timeout for run loop. Right, so we say, so we run the loop immediately, right? And if it's the first time, it will be 1, right? And then we'll basically say, if it's not 2, we'll set the timer and run the loop again in 50 milliseconds. And otherwise, okay, otherwise we'll wait 50 milliseconds and check the result. Right, so that makes sense now. Right? Element must be a function. Okay, timeout is a little bit backwards. Okay, now. We still have the same result, but at least now the code makes more sense to me because we're saying we run the loop, right? And we don't check the result until the loop ran twice. And each time we wait for about 50 milliseconds. So let's do this. This could be like a weird race condition. Nope. Okay. So that's really odd now. Okay, let's see what's happening here. Quick thing we can do, we can make this 100. Okay, so now 50 was debounced twice. But no, it's actually just one. Okay, so it seems like it's not, okay. The weird thing that I don't fully understand is why, if you do 2 times 50, right? So we do the first time out of 50, it runs the loop. And then we do another time out of 50, so it should have passed 100 milliseconds, right? So why then did it not do our thing, right? It could be a weird, okay, so, I'm a little bit dumbfounded at this point. Shouldn't be 1 for 50. Oh, okay, we looked at that, right? So let's make our existing test work again, right? So the one that worked before, right? So here we got this. So we run the loop one time, 5 times in a row, really quickly, right? And then we say, if the loop, this reads stupid. So what we'll do instead is, if loop runs is smaller than 2, right? Then we'll actually run the loop again. Otherwise, we do the check the results. Okay, fine. So what's happening? It's running. It waits. It gets here. It says, okay, loop runs now are 1, right? Because plus plus loop runs applies first, so it becomes 1. It's still smaller than 2, so then we'll run the loop again. And then it will basically get here again. It will count, so then it's 2, so it's not smaller than 2. Then it will set a timer to check the result, also in 50 milliseconds, right? So, and here we basically call run loop one time. And then it doesn't work. So what if we make it, make this 100. Okay, now it works. Interesting. What if we make this 55? It doesn't work. Okay, so let's put a little log here. I'm not trusting myself anymore. And then here we say, so running loop, checking result. Okay. If we do make this longer, okay. So not entirely sure. I'm using tape. I do. So tape is this really simple test framework. It's based on Tap. There was like a Node.js runner called Tap. This is what this is based on, and the idea is that it gives you this kind of output that you can use, that you can read as a human, but also machines can easily parse it. That's like the whole idea about tab, the tab format, and tape is a tab runner, so to speak, that works in the browser as well. So that's why we can, for instance, say I'm just going to run Budo, and I can actually run the test directly in the browser. I like this more than, for instance, Mocha. Mocha is also very nice graphics, everything. Works really nice in the terminal, also in the browser, but it uses globals. You know, like the whole before after stuff. Like you never know when it's actually really executing. At least to me, it was confusing. Here we're just basically using JavaScript, and then we just call assertions on the T, and then we tell it when it's done. Very simple. I like it. So I'm still. I'm going to skip this one, or later. I'm still not sure why this is not working. So if we set either one to 100, it works. So what we probably should do is well, the thing is, you can use something like faucet to get colors. So let me actually show that. Do I have faucet installed? Nope. So what you can do, you can install faucet. You can either install it to your project or, actually I'm not going to do that. So you can either install it to your project or globally. Most likely you should install it to your project and then pipe into it. So I think it's by sub6. So this one basically will take the tab output, right? So you run a test with tape, you pipe it into a faucet, and it will then have nice, pretty colors. And I think you can even do different options of what it's supposed to look like. So that's if you, but yeah, if you like exactly what Mocha does or whatever, you should just probably stick to that. It works. I just don't like the main thing that the main problem I have with it is that it uses globals also. I don't like globals, like describe and all these things, and they come out of nowhere. So for instance, you cannot just run your file. So basically, like, I can just run my file here. I'm just basically every time I run this, like, it runs my file directly. With Mocha, you have to run with Mocha, right? Because otherwise, where does the describe and the it come from? Because Mocha puts it there. So you can't just run. And then, for instance, what I want to do with Budo right now, how I do that? Now I can't just Budo the file because it doesn't work anymore, because then the globals will not be there. So since we are talking about it so much, I will actually just Budo this file. Maybe we'll find the problem that we have. Budo test. So now what we'll do is we'll launch the server on 9966. So we can just go here, localhost 9966. So now what will happen, it runs the test right here. That's how easy it was, right? And then now every time I refresh, it will run the tests again. Now what I can do is I can go to my sources and should be able to go into my tests. And now I can basically debug through this. So what I'm actually going to do, I'm going to make sure this is actually working the way it's expected to work. So let's refresh. So I got 1, 2, okay. And actually what we can do, also we can put a console.time. Now we're running this with Budo in here. Hey, Amola, I still have problems saying your name. Amola Landra, how are you doing? Maybe you can help us. We're having some really interesting problems here. Things are not working as expected. So I think it's console.time. Yeah. So basically that will tell us. Nope. I'm doing good. Trying to figure out what is going on. And I think someone just followed me, which is awesome. Thanks, Amor Landra, for following me. So basically, like the problem that we're having right now is I'm not trusting my 50 milliseconds here, but it should be fine. Okay, so I have no idea why this is not working. What I wanted to actually figure out is like how I can make time there's some time thing. Oh, I think you have to do time and then you have to do time end. There you go. So then that tells us, okay, so what we'll do is we'll we make sure that we're actually doing this every so often. So right, we basically put a console.time here, and then we put a console.time end here, and we put another console time here and put a console.time end right here. So we should actually know now that each of these takes exactly the time we want. So this is not a node inspect equivalent, but it's called Budo. So basically what we're making use of with Budo is, so I had that here. With Budo, we're making use of the fact that this is all running in the browser. This doesn't even have to run a node, right? This is just pure JavaScript. We're not using file system. We're not using anything like that. So this can run perfectly in the browser. And thus, we don't need node inspect. We could also run it with node and then do node inspect and then debug node itself. But this is much easier if you're in the situation where basically your stuff just works in the browser. So now I just have to go back here, launch this again. Okay, and then refresh. Okay, and remove our breakpoint and see, like, so let's do this again. So in the console now we see 50 milliseconds roughly, and then another 50 milliseconds. Should have been a total of, right? I think you can even name those. So let's do a console.time total, and then we'll end total. This is not available in Node as far as I know. So yeah, no problem. This is a really cool tool. There are more tools like this out there, but this one is nice. So yeah, 104. So what the hell? Why? Why is it not doing that? So we're doing 5, we're waiting 50 milliseconds, right? Then we're doing 5 more, waiting another 50 milliseconds, 100 milliseconds pass, and that means that our debounce function should now have been called. So what I'm actually going to do is I'm going to be a little tricky. So dot, we're going to do time debounce default. And then basically with here, when we actually get called, we're going to see like when we actually get called. Okay, so now if I put, for instance, here 100, I want to see when we actually get called. And now you see how nice it is. I can just refresh, boom. So debounce, see we got called at the very end. Oh, I get it now. Okay, who wants to tell me? Okay, whoever tells me what was wrong here gets a sticker. I have them actually right here. I will send you a sticker. Let's say this cool sticker, that one. I will send this cool sticker to anyone who within the next 10 seconds tells me what's wrong, because now I know. Okay, no one? 10, 9, 8, 7, 6, 5, 4, it's a really nice sticker. 3, there it is. 2, 1. Okay, I keep the sticker. So what's wrong? Well, debounce says there has to be a pause for 100 milliseconds, right? Well, if we do 50, and then we do stuff, and then we do another 50, well, there still hasn't been a pause for 100 milliseconds. So we actually need to wait 100 milliseconds, right, after we're done. Does it make sense? So what should happen here? So we need to put the 100 milliseconds here. We just need to do that. So let me actually undo all this time stuff. Does it make sense? So if anyone not understanding what's going on, because it's a little tricky. That's why I was confused myself. So basically, it's not the total time of how long we did call this function for, right? It's since the last call, they need to pass 100 milliseconds until it actually then calls that function, right? It waits for 100 milliseconds, and then it says, okay, for 100 milliseconds, there was no more call, and that's why now I'm actually going to call the original function. But in this case, there was no 100 milliseconds pause because we did it. We called it a bunch of times, 5 times. Then we waited 50 milliseconds. We called it another bunch of times. And then we waited another 50 milliseconds. Well, and at that point, it didn't call it yet, right? Because there was only ever a pause of 50 milliseconds, but it's waiting for a pause of 100. So this is that. So now this should be fixed. Okay, cool. So actually, our test was wrong. And that's the difference, by the way, between immediate debounce and non-immediate. So since it wasn't immediate, it's actually waiting before ever calling it. With the immediate version, which we'll see later, it will just call it once, and then it will wait, right? And then if only once 100 milliseconds pass, then it will call it again. So it will always be at least one call. But since we're not using immediate, since we have set that to false, it doesn't do that. So now this is interesting. So basically now we have we're waiting 50. So actually for the other one, we should see it twice, because what's happening? We are calling it 5 times, right? Then we're waiting 50 milliseconds. At that point, it should actually call it once, like the other version, right? Now, yeah, it's misleading. So now, and so it's again, Richard. So if you call 5 times, we wait 50 milliseconds, right? In that case, the 50 debounce count should go to 1, right? Because now it should have called it once. Then we are running it 5 times again, and now we wait 100 milliseconds, right? So that's more than 50, so then it should call it again. So at that point, we should see it twice. So let's see if that actually works. And it doesn't, it called only once. So that kind of tells me that either our 50 millisecond didn't ever make it there, like that configuration, right? Or something else happened. So what we'll do, we'll actually put a breakpoint and see that things get configured correctly. And by the way, this is we're going a little over time, but this is kind of fun. So I'm going to do this last thing. Hopefully we can fix it, and then I'm going to sign off, and we'll have to finish the debounce properly later. So let's see. So this is the actual debounce module. So this is kind of confusing. Okay. So now this is our debouncing. Now we need to make sure that when our decorator gets created, right, we get actually passed this as a config. All right, so let's do that. And this now, you can see like the cool thing when you just, yeah, debugging is fun, right? Like, especially if it's that easy, boom. This should be the first method. So this is on debounce default, right? We can kind of see that here. So it's calling configure debounce here. The config should be null. Or there was nothing in it basically, so that's fine. Now we should be called again, and this time, okay, so our config actually made it here, so fine. So we configured that correctly. So now we should also get 2 calls in here, right? And one should have wait 50. So let's see. So we got the first one, and wait 100, blah, 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 and it comes from apply decorators, where we are passing the decorator. Look at that. There's no config on there at all. Something went horribly wrong. Because even though this is like the default one, we should still see a config. So now we probably get nothing here. Yeah. So somehow our config didn't survive to here. So, oh, look at that though. Ah ha ha, look at that. We gotta wait there. We just screwed that up somehow. something that might take you hours if you can't debug. So what are we doing here? We need to actually let's see. I think we need to do it this way. Right. Ha. So basically what we were doing, we were giving it whatever is in the config and overriding it with that. So then it would apply weight and whatever else we attach to the config. But what we need to do, we need to actually make this its own property. So now I bet you it will work. Woohoo! Okay, cool. As I said, it was going to be the last thing that I was going to do. And basically, the debounce is in pretty good shape. Yep, I agree with you, idea. And the thing is, that's why it's so cool that that's one thing. So be like, we'll push this up. We won't publish a new version. We'll actually put this in a different branch because it's not ready for master yet. So let me actually do that, and then I'll say something to what Hideo just said. So let's see. So we'll fix some stuff in. So yeah, actually, so the bind fixes we will apply to this branch, right? Because we made some. So let's just review those. Decorators bind, right? So we did there. We basically fixed the GitHub repo, right? So so basically bind fixing ULs and package. Okay, and now so we push that to master, and now we're going to check out a different branch called debounce. Okay, and we actually add the decorators and deco. Actually, let's reset that a second, because we will do this in 2 steps. Because we're going to say, first of all, you know, like the logical thing would be that we passing on a decorator config if present, right? That was kind of like we did this all together, but that was kind of the prerequisite that we needed to make the debounce one work. So debounce working version respecting weight. Okay, so that's cool. Now we're going to go here and we're actually going to add this to the tests. Deco, change bind for debounce. All right, and then run dec test deco debounce. Okay, and that, boom, boom. All right, cool, everything's passing. We add that, debounce, running tests as part of deco. Cool. And so just make sure we're on the right branch. Okay, cool. So now we'll push that to the bouncer. So what we still have to do, we still have to make sure that the immediate gets passed on, right? So at this point, it should already work because we kind of already have that code there. But I want to at least add a test to make sure that that works properly. And then we should be done with the debounce one. And at that point, we'll probably like, we publish the debounce package. And then we'll see from there. Maybe then we'll just leave it and hope that others like you watching will contribute some cool decorators. That'd be awesome. Now I wanted to explain about the debuggability part, right? So this is, so I'm just gonna do it this way. So the whole debuggability, we just saw how much it helped us that we were able to quickly just debug it, right? So node inspect obviously makes that easier for node in general. But then still, like what you need to do, you need to start it with node inspect, right? So what would happen is you start your file with node inspect. And then you have to make sure that it actually breaks, right? So you actually have to say break on the first line, because otherwise the test would finish before we could even debug anything. And then we could debug once, right? And then we could have hit some breakpoints, look at stuff, and that's all really awesome. But the thing is, then the process actually finishes, right? So then we have to go back to the terminal, restart it again. Not too much of a pain point, and definitely if you have a larger program, makes sense. However, being able to debug in the browser is pretty big, because as you could see, we just run it, right, with bootto, and basically bootto doesn't run the program; it just serves the program. And then every time we refresh the browser, it runs over and over, so we don't have to go back to the terminal, restart. It's actually a lot easier, and that's a good argument for keeping your code very separate, right? So in this case, these decorators, right? Let's just say I'm doing a node project and I want to also do a decorator for file system for whatever reason. I don't know if that even makes sense, but I would still keep deco code totally isolated from that, and I would keep the test as isolated as I could. So basically, I can still run small parts of this code, right, without having to necessarily run it with Node, right? Because why would I have to do that? So it's a good argument to keep your code very modular, keep it very small and isolated. So then you can see, I can run it like this. I mean, a bad example would be what if I came up with this decorator idea in the middle of a node project, right? And then I'm applying these decorators already, and they're part of my node project, and they're part of classes that are actually running with Node, and now I run into a problem, right? Now it's really hard for me to test this all in isolation. So instead, what I would always do, I would say, okay, this decorator thing is clearly an isolated thing. So I'm going to implement them in a separate project, and I can run these files in isolation, and I can run it with bootto, and it's much easier to debug that way. So when I finish with that, I hope everyone enjoyed this stream. As I said, we'll continue. I can't tell you exactly when. I'm hoping that I will be able to do it next week on a Tuesday. So we'll shoot for Tuesday next week, because I cannot do Wednesday next week, so we'll have to move it by one day. But after this, after I'm signing off, I'm going to put something in the channel. You can always go there, by the way. I'm just going to, well, you can see it now. But once we stop streaming, you will see there's always a little picture while I'm not streaming that tells you when the next one will be. Most likely will be in about 6 days on Tuesday. We'll continue where we were. We finished the bounds, and actually, if we do it in time, I wanted to actually get into some async await stuff. I wanted to play around with what can you do with async await, how much nicer does your code look, what kind of things do you have to use promises for, and so on. So that'll be also very interesting and fun. So I hope you join me for that. And with that, signing off. See you next time. Thanks for watching.